Hello and welcome to another Solana tutorial. Today we're gonna talk about basics again. We're gonna go through the transaction life cycle. Like, how long does a transaction live? What do we even mean by that? Like, how long is a transaction valid? And then we're gonna talk about retrying transactions, and what this really is about. We're gonna attempt to send a transaction on Mainnet while it's congested, because I think it still is congested. It got better already, but we're still experiencing, delays when trying to send transactions. And those delays can lead to your transaction not even landing if you're not doing it right. So we want to learn how we can resubmit transactions, what's some best practices for doing that. And yeah, basically just learn more about how Solana transactions work. That's what we're going to do today. And I'm hoping that this one is going to be a short video, and I don't promise anything because people keep complaining, hey, this could have been a 10-minute video. Shut up and do it yourself. I want to do deep dives, and therefore I digress sometimes to provide you with more context and more information. And at the same time, I'm trying to be quick here. So let's get started and not waste more time with the intro. First thing we want is, of course, a key pair, as always. Solana keygen, grind me an address that starts with TX live. And then we need some SOL to work with this. And since we're gonna work on mainnet, I can't just airdrop myself some SOL, but I need to actually find some in my wallet. I mean, here we have 0.1 SOL. I'll take that. I want it all. I want it all. I want it all. And I want it now. Mainnet is working. We do get transaction confirmations relatively quickly when using Solflare, but they also have relatively high priority fees, 300,000 microlamperts per compute unit, and amounts to a total of 65k lamperts we spend on that transaction. Quite high, but I guess that's what you gotta do. Is it what you gotta do? We'll find out. Let's build ourselves a super simple script that sends a transaction. I basically just stole the code from last time. And the only difference is we're gonna use mainnet and we're gonna use the public RPC, which is probably the worst one that you can use, but we're gonna use it on purpose because we kind of wanna have transactions not land. You probably want to use your custom RPC, like one with a proper provider, because this one rate limits you quite quickly. But anyway, we're gonna use it. We get the key pair, we build a transaction, set ourselves as the fee pair, and just so we do something, let's send some SOL around. Let's do a system program transfer instruction to, I would send it to a receiver, right? But for all intents and purposes today, I'm gonna set myself as the receiver just so I send it in circles because I don't have that much SOL on mainnet. The seeds and program ID and the base pub here, we totally know what that is because there is a video on that side that I made a long time ago about create account with seeds. But we're not talking about that today. We just sent some lamperts and we send, I don't know, 100k lamperts. Because again, I'm not rich. Then we can of course simulate that stuff just to see if it would work. And true, maybe we should add that instruction to our transaction. There we go. And then we get success. But let's not just simulate this. Actually, I don't want to simulate at all today. I want to just send it, sign with that key pair. We're going to send and confirm and see if that also works on mainnet. Let's do it. That's the simplest way how you can send a transaction. And I'm just going to talk now because maybe it's not going to work. Maybe it is working. But it certainly is taking some time. That's why I'm continuing to talk right now, because you need to see how much time is passing so that I don't just use video tricks to skip that time, because actually a lot of time is passing between when we sent it and the time we actually got that signature. Wow, there was a lot of time. But the good news is that transaction actually landed, even without priority fees. Let's try it again and see if we need to wait as long as well. So I'm gonna again have to keep talking. See, that's why my videos are so long, right? This could have been a 10-minute video. Shut up. I need to demonstrate that it takes forever for us to get a signature. Otherwise you wouldn't believe me, right? You know what, I'm gonna still edit this. There we go, we have the signature after a long time of waiting. And again, we did not use any priority fee. But maybe those transactions just go through because there's not a lot of demand for block space right now because it's Sunday morning. And if you're looking at the time down there and saying it is not morning anymore, Andy, then, well, first of all, in the US, it is still morning. And secondly, for me personally, it is also still morning. I basically just woke up and it's 1337 p.m. Good time to have woken up and send transactions to Solana mainnet. Okay, cool. So we can send transactions. Congratulations. Well done. What's the video about? I mean, we were able to send transactions all the time, always. Is that so? Did you manage in the last month to always send your transaction if you wanted to? Well, if you did, then congratulations. Cool. Maybe you just have a great RPC provider, or you're not ever sending transactions. Or you got really lucky. But often when we send those kind of transactions, they will not land because we're not using priority fees and we're not using a good connection. Even though I'm not actually sure if I actually don't know, maybe the mainnet RPC thingy is actually pretty good, but they definitely do rate limit a lot. Anyway, I mean, this is great now and also a bit unfortunate because I wanted to demonstrate what to do when that stuff is failing. So maybe just for my own entertainment, I'm curious if I would add a compute budget instruction. Let's do like Solflare did with 300k microlamperts per compute unit. Let's see if that transaction would land faster or would be confirmed faster with the same RPC connection. So again, I'm gonna keep talking here until it doesn't really look like this is much faster. Nope. No, does not look faster at all. Still waiting for it and it's still not coming through. Eventually it will come through or not, but it looks like there's no real difference if I use priority fees right now or not. Okay, and we could totally make a point that priority fees are absolutely useless. In this case, even counterproductive. I mean, look how long I'm waiting for this. What the hell? See, but the thing is, maybe this time we just got unlucky. Or people are finally waking up and using Solana mainnet. Eventually, this thing will come back with an error and tell us, sorry, we couldn't confirm that transaction and the block hash has expired because the confirmation strategy is using a block hash. And that's exactly what I want to be talking about. So great that it's finally working the way I expected to, which is the transaction doesn't land. This is of course not saying that priority fees don't work or are counterproductive. Oh, there we go. We got a transaction. Wait, did that one land actually? Yes, it did. But like, why did it take so long to confirm this? And see, I paid a lot more gas and it did get confirmed like a long time ago, but apparently I didn't receive the info for that. Yeah, whatever. So we're gonna build ourselves our own logic for sending because this is a bit unstable. Because if you're anything like me, you are impatient and you definitely do not want to wait or have to talk for a minute until that confirmation comes back. It's just way too long. So forget that again. And we're going to once again split the sending from the confirming and just here say send. For that to work, we also need to sign, of course. And we need to set the block hash before we sign. Okay. And if we do that, guess what? We're gonna get the transaction signature much quicker. Boom, here it is. But what is the problem? Obviously, we did not confirm that signature, so we don't actually know if it landed. It did in this case, but we cannot be sure that it actually landed. So what we gotta do is check if it actually landed. And we did talk about those things when we talked about commitment levels, you know, like the transaction confirmation status. In that video, I still use the wrong hand every time. That video, confirm transaction. And there we need the strategy again. And we're gonna use the strategy with the signature, which is this one. And the block height stuff. Well, there we go. So first we get the signature and then we still confirm the signature. So that's what's taking so long and that's why we're waiting. We could already, you know, check that in Explorer and it will probably show up. It does, but apparently here we're still waiting. So it seems to me like the PubSub of this connection, you know, the WebSocket subscription that this thing uses behind the scenes. Do you have the implementation? No, I don't. But yeah, I'm pretty sure that uses the WebSocket connection to check the confirmation. But yeah, so that part seems to be quite slow. The Explorer already got it. But that also means like it's pretty like safe. But also it didn't really give me a confirmation status. Literally said nothing. Wait, let me do that again. No error, but we used to get like more details about that. Let's keep confirming that stuff. Oh, there we go. And then we get the confirmations with finalized. So apparently for that public endpoint here, it's just not particularly reliable, that confirmation stuff. It came back with nothing, also not an error, but then it came back with what I would expect, like, what's the confirmation status? Finalized. Okay. Probably if we would use a different RPC, it would be, you know, different. Helios. So if we use Helios RPC, then... and we get rate limited. Okay, don't use a free Helios RPC. This is pointless. As remember that for crypto in general, if you get it for free, it's probably a scam. Anyway, so yeah, okay, no Helios RPC then. Get a paid one from Helios if you need to, or from any of the other providers. This was a pointless excursion. Your video could have been 10 minutes long. I know. Let me do my thing here, okay? Yeah, this one is... It's weird that it takes like a while and then it confirms it with finalized, but at least it doesn't rate limit me at that point. But let's say you are a little bit like me and you're super impatient and you want that confirmation way quicker, because otherwise you're gonna resend that transaction or whatever. Somehow, fortunately, but at the same time, unfortunately, all the transactions that I'm sending here actually do land on the cluster. But what would happen if they wouldn't land? And let's simulate that by simply not sending it. And then where do we get the signature from? Well, did you know that the signature is already present here because we signed, therefore we have the signature. The signature we don't get back when we send the transaction, even though that's what happens when you send the transactions, you get the signature back as the confirmation kind of. But really, the signature, you provided the signature to the RPC when you sent the transaction. The signatures are part of the transaction. And here of this transaction object, this even has the signatures as an array. So dot signature gives me the signature. Or I could say signatures, that gives me all of the signatures, and I can get the first one. Those are public key and signature pairs, and from that I get the signature, which is the same thing as just saying signature. But that's a buffer, so where I can print it. Hold on, log the buffer just so you see which format that is. You know, that's the bytes of the signature, which is 64 bytes, right? So this roughly, I don't know, 50 plus 14. That's a signature, but we are not used to seeing it like that. We're used to seeing it base 58 encoded. So let's BS 58 encode this stuff. Can I get a BS unsigned integer 8 array from that buffer? You happy now? I'm saying you definitely have a signature, otherwise you can just fail. That's okay with me. And then the signature looks like what we are used to, you know, such a string. And it starts with 5, so it's a good guess that we have 64 bytes. Signatures usually start with the letter 2 to 6. We figured out in our base 58 encoding video. I used the right arm this time. Haha, I'm getting better at this. Anyway, so this is a signature, but it's not a valid signature of a transaction on Mainnet because obviously we did not send it. So we can attempt to confirm this, but that's obviously not gonna work. I mean, yes, it is gonna work, but we're not gonna be able to confirm it because guess what? We didn't even send it. And yeah, this is gonna take a while now. We are gonna sit here for a minute. Your video could be 10 minutes long. Shut up! Let me make long videos, okay? Eventually, it's gonna tell us, sorry, we could not confirm this one with this strategy that you provided. And what is the strategy that we provided? Well, a signature and block hash combination. And that block hash is the block hash plus the latest block height. Those are the two things that we provided here. The other way to do it is with a nonce, if we would have sent a nonce transaction, but we didn't. So it came back and we got a transaction expired, block height exceeded error. What does that mean though? that the transaction with this signature here has expired. So it's not a block hash not found, it's actually block height exceeded. So we're definitely over the time of that block hash now. So it's not about the transactions block hash, it's about this one. And the transaction couldn't be confirmed with this block height. What does that all mean? Why block height? What the hell are you talking about? If you're missing the basics here, don't worry, I got you. This is exactly why I'm making this video. So, a transaction is valid for exactly 150. Wait, no, that's not true. A transaction must have a recent block hash that is within the last 150 recent block hashes. That's why this system variable has exactly 150 entries. So if it's within those entries, like if that field in the transaction, the recent block hash, which is a field in a serialized transaction, also in a transaction object, and it's called recent block hash. But when we serialize it, we put that as part of the message that we then sign. So we first need to put the recent block hash and then sign. Otherwise, obviously, the signature is going to be different. And we do that such that our transactions expire. That's just a security thing, such that it can't be resubmitted later. Unless, of course, we're using durable nonces, but that again is a topic for a different video. Durable nonces. I'm getting better at using the right arm. It's the left arm that's the right arm. But anyway, so we query a recent block hash, we put that in that transaction, sign and send with this block hash, and then basically it's valid for pretty much 150 blocks. Obviously, it took some time for getting the most recent block hash, because guess what? They are changing. When a new block is built, there's a new recent block hash. And that is actually changing quite quickly because we're building quite a few blocks on Solana every 400 milliseconds approximately. So how long does it take for 150 blocks? Well, 150 times 400 milliseconds is what? Exactly 1 minute. So a block hash is valid for at least 1 minute. So the minimum validity, if we have the most recent block hash, if we sign a transaction with that block hash, then that transaction is valid for at least 1 minute. Why do I say at least? Well, because for one, it can happen that the cluster is a bit slower than the target time of 400 milliseconds, because our current slot time, 1 minute average, is actually 500 milliseconds, not 400 milliseconds. In the last hour, it was 400 something. So that's the one reason why it bumps that minute up a bit. And the second reason, not every slot might build a block. Like there might not be a block in every slot. That's why the block height is different to the slot height. So we're already in slot 264 million, but we only produced 243 million blocks. Because, you know, if a validator is too slow or doesn't have the right state or produces a block that ends up being on a fork, those blocks then are just not included. So therefore, this is a bit lower. But still, it still holds true that the last 150 block hashes are valid, and if no new block is produced, then that system variable is not updated, and the old block hashes still stay valid. Because obviously, we want to always have valid block hashes to build new transactions with. Because assuming that the cluster would, you know, stall and not produce blocks for over a minute or two, if we would go by slots, then we would not have valid block hashes anymore and we couldn't even send new transactions, and then we're basically screwed and, you know, have to, I don't know, start a new blockchain or whatever. And we definitely don't want to do that. And so therefore those block hashes stay valid until a new block is produced, and then that replaces the oldest block hash, the 150. That's how that works. So it's at least a minute, but possibly more. And they probably chose that value, like they probably chose 150 exactly so that it is a minute. Like that is just a design choice. Why is it 150 blocks? I don't know, arbitrary number. Well, probably that it's exactly that 1 minute, because 1 minute, that's something that, you know, humans are used to. Same thing with the epoch length. there, that number also seems so arbitrary unless you do the math, because then you get exactly 48 hours, which is 2 days. You know, arbitrary numbers really. Just so that the ideal target times are numbers that are nice for humans. Is my assumption, I don't actually know. This epoch actually takes more than 2 days because we are slow. Okay, so we learned, okay, they are valid for 150 blocks. And if we can't confirm it within those 150 blocks, then we can be sure that, well, that transaction has never been sent. This transaction, even if I would give you the serialized transaction with my signature, you could not submit that to the cluster, right? Even if I sent you like 10 sol or whatever, if the transaction is not confirmed after those 150 block hashes have, you know, run through, more specifically, the block hash that I queried here is not within the 150 most recent block hashes anymore, then you can't do anything with that signature for that transaction. It's just useless. And let me demonstrate something else, for which I'm just gonna quickly print myself the block hash. Let's take this block hash here, for instance, and we signed the transaction and it gave us this signature. Now check this out. If I'm now not using this block hash, but that thing, guess what? It will give me the exact same signature. Why? Because we built the exact same transactions with the exact same instructions down to instruction data. It's all the same. And also the block hash is the same. Therefore, we get the same signature. And now the even more funny thing is, if we now actually send that transaction, check this. Here we get back to our classic block hash not found, which we had in the previous video because we were too fast, but this time we are too slow. That block hash is not within the last 150 recent block hashes anymore, and therefore even the simulation of this send raw transaction tells me that this transaction will never land because the block hash is not found. Even if I were to skip pre-flight, it doesn't matter. Then it would give me the signature, which is the same that we had up here, right? The 2K. But still, the validators will not accept it because it doesn't have a valid block hash. And we can try to confirm it and we will just get, we can't. But that whole thing is actually kind of a good thing when it comes to retrying transactions. Because what happens if I send that transaction 2 times? What do you think will happen? We get 2 signatures? No, we still get the block hash not found. Okay, fine. Let's use a valid block hash again. And indeed, we get twice the same signature. Why? Because it's the same transaction, therefore it will have the same signature. Which also means we cannot really tell those two apart. So if we were to go here to confirm it, this one is not a different one. There we go, it's already finalized. It's not a different one to the other one because that one also has, of course, that same signature. And we didn't really see what's happening there because it happened so fast. But let's say we wait a bit in between. I don't know, wait 10 seconds for the RPC to catch it. So we send the transaction once, then we wait a bit, and then we send the same transaction with the same signature again. What will happen? Okay, it will just work and we get confirmed because it was just confirmed, and then eventually it will get to finalized. Not what I wanted to show. Let's wait 15 seconds then. So we've sent the transaction. We wait now for 15 seconds and we sent the exact same transaction again. What's gonna happen? Hopefully the RPC will tell us. No, ain't gonna tell us anything. He's like, okay, I submit that again for you. No worries. You know what? Let's do that. Confirm it and then send it again. Because what will happen if we confirm it and then try to send it again, then hopefully it will tell us the thing that I want to show you, which is that it's going to tell us that this transaction has already been processed. There we go, finally. We just have to wait a bit longer, but then we get this nice, this transaction has already been processed. Because guess what? This transaction has already been processed. We got a confirmation. Well, did we get a confirmation? Not really, but the same transaction has already been processed. If you put in the exact same message, so the message bytes are all the same, and you sign with the same key pair, then you produce the exact same signature. and Solana will only accept that signature once. Why is that important? Well, for deduplication reasons. Obviously, your transaction that you send to one RPC might end up at different validators. You know, maybe that one leader couldn't include it and then it sent it to the next, but then this one also sent it to the next and then one guy received it twice. And what we definitely do not want to have happen is that our transaction changes the state twice, even though we just signed once, right? Let's say I would send, my 100,000 lamperts to a receiver and I want to do it once, of course. I don't want to suddenly have sent 200,000 just because the transaction was accepted by 2 validators. That's not how this should work. One transaction that I sign once can only be put into a block once. And that's done via the transaction signature. If the one signature, like the first signature, is the same than any other signature that has already been processed, then the validator will just not accept it. And the RPC already tells us this, gives us this warning. Transaction has already been processed. We can't send it again. So that's why here that one works, but here this one fails on us. And I don't know how it works behind the scenes, because obviously the validators will not check the transaction signature against every single transaction signature that has ever been persisted. They will probably have some kind of cache for, guess what? The most recent transactions, the ones where the block hashes are still valid. Because as soon as the block hash is not valid anymore, the transaction isn't valid anymore anyway. So I don't need to remember that that transaction signature has already been processed. So they'll do some cache. I don't know how exactly they're doing it, how that is implemented. And it doesn't really matter. For us, all that is important is if I resubmit the exact same transaction, then it's not going to be persisted twice. However, as soon as something changes in the transaction, obviously it's a different transaction and I can send several of those. So for instance, if I would get a more recent block hash and then I sign this again, it is caching block hashes, and maybe if we do it directly after each other, I don't get a different block hash. Let's try. No, still the same block hash. So let's say I wait a second here. There we go. Provide one block hash, and then I provide a different block hash, but still the same transaction. Then I get a different signature when I sign again, because obviously the message changed, because the recent block hash changed. And then I get, of course, a different signature. So those are now 2 different freaking transactions that probably both got finalized. This one did, but also the first one probably did. There we go. Both of those transactions actually got sent because they are, guess what? Different transactions, because the block hash is different. And it doesn't even need to be the block hash. I can leave the block hash the same, but I could change a byte in here. I don't know how this works. It's 1 byte for the discriminator and then the lamperts. So byte 1, I just increase it by 1. And really what that does, it's doing this. Building myself a transaction with 100k plus 1 lamperts. My point is I change the message. I change 1 byte of the message and I sign again. I will get, guess what? A different signature, even when the block hash is the same. So check this out. That is invalid instruction data because apparently I did F something up. Hold on, let me check one of those transactions, expand that, discriminate. Oh, the discriminator is a U32. So the discriminator is 4 bytes, not 1. Okay, so then 4, not 1. Try that again. Send the first one, send the second one. Different signature because guess what? Different transaction. And here, there we go. We didn't send 100k lamperts, we sent 100k and 1 lamperts. And that made it a different transaction. And we don't need to even, play with the amount we send. It could be as simple as adding a compute budget program instruction, which would make it again a different signature. Again, first without the compute, then with the compute budget. This one did confirm immediately, and this one does not. Something is really weird today with the compute budget. What is happening? I can't confirm the one with the compute, with the set compute unit price, but I can confirm the one without. This is so weird. So, add a set compute unit price instruction, or, change that value here for even just 1 bit, and it's a completely different signature because it's a completely different transaction. Well, not completely different, but there's something different in the message part of the transaction, which gives us a completely different signature. Because a signature in the end is a hash, and hash functions work that way, that the hash is completely different even if just 1 bit changes. So we saw we can either change the block hash or change instructions or even just a byte of that transaction data, and it will result in a different signature, and therefore if we send that, it's a different transaction. However, if everything is the same, then it's still the same, even if we build it again. You could now build that same transaction by just knowing what the instruction data is. Like, what instructions did we do, to which program, which keys, and what is the instruction data. If you know that for all of the instructions, and you know the block hash that I used, then you can build the exact same transaction. And if you had access to my key pair, you could also produce the same signature. There's nothing to this object in here that makes it this particular way. Even if I would run this twice really quickly, if I would get the exact same block hash, which I didn't, then it would also still be the same, but I would need to cache that. So I can build the transaction completely new. It would still be the exact same signature if I have the same instructions and the same recent block hash and the same fee pair and everything. Everything needs to be the same is the point. But then, yeah, it's the same if it's the same. Thank you. This video could have been 10 minutes long, Andy. I know. Shut up. I want to make the last person watching this understand. If it's the same message, it is the same signature, and therefore it's only one transaction. Which is important to understand when it comes to retry logic. Because, fortunately for us, we don't need to retry any of those transactions because they just land. Apparently Solana mainnet got more stable again. Kind of wanted them to not land, such that we can, check what we can do when they don't land. But it's pretty self-explanatory. Basically, you want to try to confirm it, and if you don't manage to confirm it, you're just gonna resend it. There is also, in the Solana cookbook, there is also a section on retrying. Where is that? I thought there was a section in there with retry. Maybe it moved to official docs or whatever. On some occasions, a seemingly valid transaction may be dropped before it's included in a block. This most often occurs during periods of network congestion, like we had the entire last month, when an RPC node fails to rebroadcast the transaction to the leader, or the leader decides to not deal with it because it gets too many transactions. To an end user, it may appear as if the transaction disappears entirely. Yes, because it's just not accepted by the validators. While the RPC nodes are equipped with a generic rebroadcasting algorithm, application developers are also capable of developing their own custom rebroadcasting logic. Developers should take advantage of the max retries. Yes, that's what we're gonna do. That is a good point though. RPCs actually rebroadcast. Let's tell them not to. So I send this transaction and I tell you, hey, please, RPC, don't even retry. Max retry is 0. Maximum number of times the RPC node to retry sending the transaction to the leader. Let's see if this gives me a different result. Because obviously, if the RPC is already doing the retry logic, then yeah, the chance of my transaction landing at some point are actually quite high. But what if I don't let it retry? Oh, wait, hold on, that's wrong. I called it retry, where we don't retry. Let's see, can we confirm that? Please tell me you cannot confirm that. Yeah, that looks good. That's exactly what I'm used to. Sending a transaction and then not finding it anywhere. Where did my transaction go? Maybe Explorer can find it. No, it's also not here. That's more like it. That's more like what I'm used to. Yes. And then I just get nothing. And at some point, the RPC is telling me, well, couldn't confirm that. Blockhash is also not valid anymore by now. So this transaction is just not confirmed, not valid, just not there, just gone. Bye. So that was pointless. Was it? No, we learned something. Cool, right. So it's because of the max retries. If I don't let it retry, then it just sends it to one leader. And then if that leader doesn't accept it, then it just disappears in a way. It's just doesn't get accepted. But the awful thing is that this thing here is taking so long. There we go. And now it's coming back with block height exceeded. So it couldn't confirm it even within that time. Great. That's exactly where I wanted to go. So what can we do about that? Let's see if that reliably works, if we can reliably not have transactions land on the cluster. Yeah, looking good. Because then we can talk about building our own retry logic. If the RPC doesn't manage, like I always would recommend that you let the RPC do it because they have, you know, good logic as well. I would only build your own custom solution if you want to do your own custom things. If you just want to get a transaction sent, it's probably better to send it to the RPC once and hope that it manages to somehow get that land on the cluster. Because if you start spamming the RPC, then the RPC, like, they don't like it. First of all, they're gonna rate limit you, and then at some point they might block you. Spamming transactions, like sending the same thing over and over again to an RPC, does not really make sense because the RPC already received it. So if you just send it again, then the RPC is just getting more and more annoyed by having to deal with the exact same transaction. And even if you change a little bit of stuff and have it a different transaction, if you spam that transaction, some RPCs also recognize that and will also block you for it. So in general, spamming, I don't think is a good idea. I know that for some use cases, like if you really want that transaction to be persisted quickly, people are incentivized to spam, like, you know, ARP bots or whatever. But I think RPCs are doing more and more to, you know, not allow that sort of traffic, which, you know, overall is also not good for the network. That's a biased opinion. I just don't like spam because it's not efficient. I want this stuff to be efficient. Anyway, so what does this thing say? Before resigning, it's very important to ensure that the initial transaction's blockhash has expired. Yeah, that's a good point. If we get to the point where our transaction didn't get confirmed, like we got here, we need to actually make sure that the blockhash has expired before we send the same thing again and, you know, sign that transaction again. Unless we don't care if both of the transactions actually get submitted, like persisted in the cluster, right? So if it's something, I don't know, simple example, if you create a token at one specific address, you could theoretically resign that because the second time when the transaction lands, the transaction will fail anyway because it can't use the same account again. So it will error with 0x1. No, 0x1 is insufficient Lamberts. With 0x0. But if it's a transfer where you have the funds for both of them, then you really want to make sure that the block height has exceeded. It's not a valid block hash anymore before you actually resign it. Because it can happen, even though the transaction is not confirmed yet, it is still somewhere on the way, or the RPC just didn't get the information that the transaction got processed and then confirmed. And if you resign too early, it can happen that both of them get persistent. Yeah. I mean, we talked a lot about that. That video could have been 10 minutes. Shut up. I'm just reiterating because it stands here. Anyway, so maybe go through some of those basics here. Or actually, no, I will give that for you as a homework. Go through that. It's probably pretty much what I said here in this video. Maybe there's some key parts to still take away. On Solana, we don't have a mempool. Yes, that's why we need to do it that weirdly. The transactions are routed to the leaders. And we talked about what leaders are and everything in a previous video. You can submit directly to the leader via a TPU client. Yeah, we could also do that, but I would not recommend that. And in the case of the TPU client, the rebroadcasting is entirely up to us. So either we send through the RPC, which is what we're doing right now, or we send directly with the TPU client. I would say advanced users only, and since this is a basics video, we're not gonna handle that. Maybe in a future video if you're interested. UDP, it's actually by now, it's quick, not UDP anymore, so this is a little bit out of date, I guess. Because we know Solana's leader schedule, we can know where to broadcast it to, yes. RPC nodes will try to forward transactions to leaders every 2 seconds until either the transaction is finalized or the transaction's block hash is expired. That's interesting, every 2 seconds. That's apparently the logic. Well, I mean, that depends probably on the RPC and their implementation. RPC operators can adjust that default behavior and retry logic. Of course they can. So we don't know how they actually do it. 150 blocks, which is 1 minute and 19 seconds at the time of writing this. Yeah, whoever wrote this probably just took the slot time that is currently live. My answer to it is 1 minute at ideal times of 400 milliseconds is much nicer because it makes way more sense. But if I say stuff like that, then my videos are more than 10 minutes. You're welcome. Okay, so let's actually talk about this block hash here, or that block height. The get latest block hash. We usually just get the block hash from it, but it also comes with the last valid block height. And I think today is a good time to actually talk about that. Why do we need that? What's that good for? I just want that block hash. No, you will also want the block height, because the block hash literally is a hash. It's a string. It's something, right? And you can compare it with all those strings in this recent block hashes, but that is like super complicated. Why would you want to do that? When instead you could do a simple arithmetic calculation whether or not your block hash is already expired. Because obviously all you gotta do is compare heights. Each new block hash increases the block height by 1. And we know that at a block height of 150, the block hash is not valid anymore. If the most recent height is 150 or more larger than the block height from our block hash, then we can say, okay, the transaction is at that point not valid anymore. And that's why they always come in pairs. It always comes with the block hash plus the block height, last valid block height. So for instance, there we go. This block hash is at this height. And we've seen that number earlier here at the cluster stats. That's the current block height, right? And this is increasing. If I wait a bit, then another 55 blocks have been built. And guess what? The block hash is different. It is also different, circling back to the confirmation. If I query with a finalized commitment, I will of course get a different block height. Well, a bit later, but that could also be because I did that later. Nope, they're actually the same. Maybe the default is finalized. Let's check this one with a confirmed commitment. Yeah, there we go. There we see the difference. So how is confirmed already? Oh yeah, confirmed is higher. Of course it is. So we're like 40 blocks between finalized and confirmed. So that block hash is newer. The height is higher. And again, that's not because I queried later. If I have confirmed here, finalized here, then it will also just swap around because I query them pretty much at the same time. Again, it's about 40 blocks difference. This is the newer block hash with the higher block height. We could also go with processed, now in random order. That does not make any sense, which is only slightly behind confirmed. But we do get a newer one. However, I would not recommend doing this ever, because processed could still be on a minority fork, and you don't want to build a transaction with a block hash on the minority fork. Better wait that one more or two more blocks, whatever the difference is between those, to get a block hash that is actually confirmed. So I would never do this. Those two, yes, they make sense. Let's use finalized and build our own retry logic. We build our retry logic by setting the max retries to 0. We want to be responsible for retrying, not let the RPC do it, because otherwise, you know, we have double, which we could also have, right? But the RPC might not like it. And what's our retry logic gonna do? I don't know. We're just gonna retry by sending it until we get rate limited. So obviously, your retry logic depends on what your use case is. Different retry logic for different use cases. So maybe you are a trader and you do want to get that trade in quickly. Your retry logic could look something like this. You have the RPC, send it to the leader. Actually, hold on. In the most simple case, the simplest of cases, you literally spam it for 10 seconds. Or actually, what would make more sense is to spam it for 4 seconds every 400 milliseconds. So ideally, the RPC would forward it to always the next leader. So it is as if we had, 10 retries here, but we retry faster than the default setting of the RPC would do. We don't know what the RPC default settings are of the RPCs we use. So we just, use our own logic here. And basically, we can do that. It is a little bit spammy, I admit, because we don't even check if the transaction gets confirmed. We just keep resubmitting it, and then later we check for confirmation. And that's just for me. We could also skip that and say, if after 4 seconds our transaction didn't land, we don't want to send it anymore anyway. If that is your use case, then you want to have your retry logic like this, right? Maximum retries 0, because you don't want the RPC to keep trying and send it like 50 seconds after you've submitted it, because at that point that trade is gone and the transaction will fail most likely anyway. So you don't even want to retry that long. You might just want to retry for 4 seconds. We can do that. Let's do that. Let's retry. So for this block height, this block hash, we're trying to, okay, we're getting rate limited. Again, you probably don't want to do that with public RPC endpoints, because they don't want you to spam transactions. Too many requests for a specific RPC call. But if you use your custom RPC where you have that quota, that could be one strategy. In this case, I would maybe do something like maybe I should split that. And then I can adjust my delay 1 second and I wait, I don't know, 5 seconds. Hopefully that way we don't get rate limited. Wait, hold on. I thought this was not 1 second. One, another one, another one, another one. So if we keep resubmitting it every second, we don't get rate limited. And does it confirm though? Yes, it should actually. Explorer, it's already giving me finalized. There we go. We don't know if it's the first time where it already went through. Probably not. Maybe the second, maybe the third. We have no idea. If our max weight was 1, then we would of course just retry it once, but then the likelihood of that one actually landing, well, it did. Yeah, guess we were lucky. Can I do that continuously? No, this one did not land at the first time. There I would have needed to retry more often. And actually, it would be nice if I would also check in between if the transaction got confirmed. And if it got confirmed, I don't retry anymore. Let's see what else is in that. How do those docs say we should resubmit? In times of network congestion, it's advantageous to set max retries to 0 and manually rebroadcast via a custom algorithm. An exponential backoff or a continuous resubmit builds the transaction. Okay, it also doesn't do anything else. It's defining the last valid one as plus 150 and then saying smaller than the last valid. So at the last valid, it's already not retrying anymore. So that is actually the one after the last valid one, if we're honest. It's just badly named, but the logic is correct. Okay, let's not confirm. So this strategy, works if we have a fixed time for how long we want to wait. But if our use case is we got that signature from the client, he had to click that button, and we really just want to persist it, no matter how long it takes, we can wait until the transaction is not valid anymore. And then we would do that differently. We wouldn't do this, but we would do like get latest block hash. Important, I would go with finalized here. If that block height is larger than previous block height plus 150. That is a mouthful, so I'm gonna do that outside. And this way we would continue to send the transaction until it is not valid anymore. Okay, of course I have a logic error. That's when we want to break. In my mind, what I did is, if that is the case, we're not in Rust, we need those freaking braces, then we break. Let's see. We keep resubmitting them every second now until we get rate limited. See, that's the thing. RPCs just really don't like us to resubmit transactions. They want to do the retrying themselves, not have us spam. Always the same transaction, by the way. So it can only be persisted once. Even if at that point it already is, yeah, that transaction has already been processed. Again, we don't check for that, but we have pre-flight checks on here. So if the transaction already got processed, then this one errors out and we fall out of this anyway. If I were to also skip pre-flight here, which I could totally do, then I would never get that error. And I just keep resubmitting, even though the transaction, like after the second time or so, probably is already in here. Yep. But I can keep resubmitting it until my block hash has expired. And I can check if my block hash has expired by just comparing the block heights of my block hash versus the current finalized block hash. Only then I say transaction expired. And only then would I send the same transaction again, by signing a new one. I can now query a new block hash and try that whole thing again, make another loop around that, do the same thing again until eventually at some point that transaction is gonna land or not. But yeah, that could be simple retry logic. But before you re-sign that transaction, really make sure that it has expired, that the block height, not just the slot height, the block height is 150 or more above your block hash or your block hash's block height, because they always come in pairs. Yep, and I think with that, I'm gonna leave it. This video could have been 10 minutes long, but it is now 45 because I've been recording for 3 hours. Well, so I hope that you still learned something. Of course I could have made that a 10-minute video, yes. But you could have also just read that article instead of watching this video. I mean, that's a 10-minute read, but I always want to provide more content, more context, more background, more of everything. More stupid jokes. I know that retrying transactions is tiring and we don't like to do that. And ideally, the RPC does it for us anyway. We just want to submit it once and not deal with it anymore. But if it doesn't come back with a confirmation, we now know what we can do, when it is safe to resubmit a transaction. When do I need to re-sign the transaction? After 150 blocks. So essentially, after 1 minute. And possibly you might want to resign it every 30 seconds just to make sure that you constantly have something to pump out. It totally depends on your use case, how you want to do it. There is no one size fits all because use cases are different. However, for most use cases, I would say sending it once to the RPC and letting the RPC do the retry logic fully, like just sending it once and having no max retries set to undefined, then it will just continue to resubmit. And there you have the best chance actually of landing your transaction. And otherwise you might want to increase priority fees or do other tricks or submit them to different RPCs. That could also be a strategy. You submit it to several RPCs who then retry it for you. Could be a strategy. If you really want that to be confirmed, might want to test different RPCs. I mean, behind the scenes, I think that's what Solflare does. They send it to several RPCs because they can. It's just one signature. The one who gets it to a leader the fastest is taken. All the others are then ignored because the transaction has already been processed. Yeah, just some more basics for you to understand how transactions work. Because we really need to understand that to then write our own custom retry logic, if that is something that we really want to do. But I guess with that, I want to end it. You can watch some other videos. Again, I can recommend the one on confirmation status. And as always, make sure you subscribe, like this video. I'm already getting tired and I need a break. And I will see you in the next video.